if you're not comfortable being recorded, you don't want to be recorded, we ask that you kindly drop out of the session now. Lifesaving Victoria and Fitness Australia would just like to acknowledge and thank our partners on this initiative. So we've got Royal Lifesaving Australia, Commercial Aquatics Australia, OTM Planning Group, YMCA Victoria, the Victoria State Government Health and Human Services Department, Belgravia Leisure, Cleaning Melbourne, VACA, Align Leisure, our Watch Around Water accredited facilities, Ecosave, and of course Western Leisure Services. So I might hand over to Jeremy here, Jeremy, you might have to unmute yourself and just you'll be able to sort of present your screen from there. Thanks very much for coming onto the AFAR series, and welcome all the listeners. Can't hear you, Jeremy. Don't know if you're still on mute.
Okay, thanks, RJ. Good morning, everyone. Is my screen up, RJ?
Yep, loud and clear, and we can see your screen perfectly. Thank you.
All right, no worries. Yeah, thank you for the opportunity to present to the group. Obviously, as we know, energy efficiency and saving energy, which is saving money at the moment, is pretty appropriate, with no doubt everyone, having a small downturn in income from their facilities, but we'll get into that in a second. I just wanted to briefly discuss what we'll go through today. So I'll just run through a bit of an introduction to Ecosave. I'll talk about what we call energy conservation measures, or ECMs. Basically opportunities to save energy in your building. We'll look at building automation and controls, pool and space heating systems, building cooling systems, air conditioning and pool hall air handling units, pool plant and pumping systems, domestic hot water, and potential ways we can engage on an operational level to improve efficiency. So a little bit about me. As RJ mentioned, I'm the head of Ecosave Automation. I've been with Ecosave for just over 2 years. I specialise in scoping equipment and optimising building automation and control systems to maximise the efficiency of that equipment. I've been in the HVAC industry looking at control systems for 10 years, and previously spent around 10 years in the advanced manufacturing and automation engineering sector. Ecosave. Ecosave is Australia's largest independent energy services company. We're specialists in performance-based energy efficiency solutions. We offer guaranteed energy savings projects. We're a global company. We have offices in the States and across Australia and New Zealand. We've been around for 18 years. We have a multidisciplinary engineering and trades team. So everywhere from mechanical, civil, electrical, into actual trades and installation employees. We're basically a single point of contact for turnkey solutions in energy and water efficiency projects. Important to note, we take a holistic approach to facilities, which is we don't look at one single item in your facility. We look at the entire building as a whole and try and maximise the efficiency of the entire building. We've got a range of expertise and experience across a range of councils, specifically these ones to do with aquatic and health and fitness facilities. So before I get into energy conservation measures, I just want to talk a little bit about energy efficiency in general. We've obviously all seen how clean and clear the air around Melbourne, if you're in the CBD, has become, and if not in Melbourne, pictures on the internet of people being able to see the Himalayas where they couldn't before. So there's some obvious benefits to reducing our emissions from a clean air perspective. But yeah, aside from obviously the quality of life we can provide for future generations, one of the most interesting aspect, and no doubt of of a lot of interest to everyone here today is the financial benefits of energy efficiency. And what we do is we work out in our ECMs ways to save money and create a return on investment that looks attractive to councils and businesses alike. As we all know, heated pools are probably the largest carbon footprint in a council portfolio or anyone's portfolio if they're heating a pool. So with that obviously comes the associated cost to do so. So where you might normally say you've got to spend money to make money, in this case, you've got to spend some money to save some money. As I said, probably quite a few of you today are sitting there looking at the current operating costs of your facilities, particularly with the loss of income. So essentially what we do, and particularly in aquatic centres, is we can arguably save, without even looking at it, somewhere between 40 and 60% of your energy costs. That obviously becomes quite difficult if it's a brand new building and the most efficient equipment has been installed already. However, even in those scenarios, we do find that there's optimization strategies from a controls level still. So also at the moment, obviously all the pools are closed. I've seen personally there's some pools are empty, so they can do repair works. Some people have turned their pools off to save some money. Some people have turned their pools down to save some energy, or other people have just kept going, business as usual. Particularly on their larger pools. So obviously, based on our experience, we've seen that it can literally cost as much to reheat a pool from scratch as it might to just maintain that temperature over 6 months over a summer period. So when you're looking to start reheating your pools, it's crucial that you consider a few points if you want to save a few dollars or a lot of dollars, depending on the size of the pool. Some suggestions we have if you do have set point control, as in the temperature of the water coming from your boiler or your heating source, try and reheat with that setting as low as possible, like down 40, 50 degrees instead of 80 degrees, for example. If you've got direct control of heating valves, we'd recommend during the reheat process to make sure that they're fully open, which maximizes the energy that you're taking from the water versus how much energy you use to pump the water around. If you don't have that level of control, you could try turning the pool set point up, and that'll probably make sure that the valves stay open, but obviously be careful. You don't want to overheat the pool. It's a good opportunity to invest in pool covers. If you don't have pool covers, particularly on outdoor pools and you're heating them, although I would suggest most people with heated outdoor pools do have covers, even indoor pools, it will save you energy and losses on cold nights. If you have a control system where you can look at the historical data, we suggest looking at the historical data whilst you're reheating. Like each day, look at, okay, so did I lose some temperature overnight, or did I gain temperature? And if you've lost a little bit, maybe you need to turn up that boiler set point a little bit more. The other thing when you're reheating, obviously if you're adding makeup water or doing backwashing, I'd always suggest to try and do it in the afternoons when the sun's out, just to try and reduce the load on your heating source as much as possible. So obviously there's a variety of other things that we could assist with, but no one facility is the same. But yes, if I can make one common point, it's basically try and reheat as slowly as possible. Make sure you leave yourself extra time and just try and very, very, very slowly creep it up bit by bit. Okay, so I'll jump into energy conservation measures. Okay, what is an ECM? Obviously, an energy conservation measure. It's a way of saving energy. So when we look at a facility, we look at and we identify all the different types of ECMs. They can be from LED lighting, solar installation, the mechanical systems, as I mentioned, automation and controls of existing equipment. And of course, it's a bit of a catchphrase being thrown around these days, which often people aren't really sure what it is. Data analytics. What data analytics are is it's essentially you use the historical data from your control system, and it's a tool that can be used either manually or on an automated level to optimize how your plant equipment is running, and also can be used to drive proactive maintenance on your facility. So LED lighting upgrades. We all know what LED lights are. However, they're not always done well. They're a very good idea for public safety and to basically increase the level of lighting around pools. As you can see on the previous slide, we've pointed the lights up in this particular facility, so there's no or less direct glare on the swimmers. You need to look carefully at the quality of the product. Obviously, we all know what chlorine does to pool centres. Obviously, the lights you choose need to be durable for pool applications. And there's some other opportunities for pool areas and also office back areas where you can have adjustable light levels, integrated motion sensors these days to dim lights rather than turn them off in toilets and the such. Solar systems. We're getting very good in Australia at taking up this this type of ECM. Everyone, you see them everywhere in residential areas now. Basically, if your roof can support the weight, it's an exceptionally good idea, particularly in a pool where you've got pumps running 24/7. And so you've got a constant base load of electricity. So what we do, obviously, is we try and closely match the daytime base load with levels of available solar, rather than just carpeting your roof with solar. We try and match it the best we can. But yeah, obviously, the critical part to mention there is that structural assessment, which we need to do before each and every project. As I just mentioned, obviously you can offset the baseload of the aquatic centre. It does show environmental awareness. It's a visible display to the community that you're taking leadership in energy efficiency and reducing your carbon footprint. There's also different options and technology available where certain panels you can have optimizers on each panel, where if you have a lot of trees around your facility, your typical solar inverter, if one panel is shaded, that limits how much you can get from every other panel. But you can overcome that if you're in a more treed area. So yeah, just a bit of a case study where we've done for North Sydney Council. We've done improvements to pumping systems, replaced a lot of lighting across the council, optimised air conditioning in different facilities, lighting controls, solar upgrades, solar hot water, voltage optimisation, and ongoing energy management. And that's part of the data analytics that I was talking about. So a return on investment on a project like that, this particular project, was around 5.4 years. building automation and controls. Possibly, and I'm not biased here, being a controls engineer, maybe a little bit biased, but you can install the best equipment in the world, but if it's poorly controlled, you still won't be maximizing the benefit from that equipment. A lot of times when we do building upgrades, everything goes to tender, and the lowest bidder wins the project. The side effect of that is basically you're going to get what you pay for, and corners can get cut, and the best possible solution and the most amount of time spent on optimizing doesn't always take place. Something to be aware of when you're looking at control systems for your facility. There's some catchphrases that get thrown around, like open protocol or open source. So what is the difference between open source and open protocol? Because you can quite easily get tied up with a proprietary system where maintenance costs from that proprietary provider over time can be extensive. Basically, open protocol means that your controls talk to an industry standard communications protocol. So yes, while anyone can talk to it, the difference with open source is anyone can talk to it, but then also anyone can reprogram it for you. So that's the critical difference. Open source means that you're not locked into any one service provider. Open protocol just means anyone can read the data from it. Bit of a display here of a chill water system that we've done for one of the councils in an aquatic facility, where we like to have a bit of a dashboard down the bottom where on any page, they can constantly see the temperatures in every pool. So what we also try and do with our building management system is we try and integrate it with the pool plant PLC. A lot of times we find that your BMS that does your air conditioning runs the boilers, but it doesn't really have any visibility or can't see what the pools are doing. So it can't see if you're doing a backwash, it can't see if certain pumps are turned off, and it just literally just keeps chugging away without being able to tell what's going on in the background. And I mentioned before, obviously, one of the benefits that you can provide from looking at a guaranteed energy savings project model over a tender model is that it becomes the responsibility of the contractor to continually make sure that they're fine-tuning and optimizing the system, because they've basically got a monetary guarantee. So in this case, it would be our money on the line if we don't save the energy for you. Pool and space heating systems. So we all know what a boiler is. Obviously, condensing boilers are becoming the preferred option in the market. They obviously are considerably more efficient than older style boilers, like your old Raypack or your old shell and tube boiler that you've got in the plant room, where you can potentially, and possibly even greater, this is quite a conservative figure, save 12 to 15% on your gas just by installing the boiler. But then, as I said, with advanced control, you can save further 7 or 10%. And again, sometimes even higher with advanced optimization and control strategies. What is a condensing boiler, and why is it so much more efficient? It basically, what it does is it uses the heat from the combustion process and the water coming in, it uses that heat to preheat, if you like, the water going through the boiler. That means we've got lower temperatures coming out of the flue, which makes it easier to pipe, and there's less risk for getting burnt in your plant room. Condensing boilers are a lot quieter. I don't know if you've ever stood next to one, but at times you can barely hear they're operational compared to those big old boilers where you're standing next to them and you're screaming at the person next to you to hear them. They have a modular design, in a lot of cases, not every case. Modular means, for example, looking at this boiler in the background here, this is a 900 kilowatt boiler, but it has 8 individual burners inside of it. So that gives it an excellent turn down ratio. So from 900 kilowatts in total, we can turn down to 22 kilowatts. So even with the smallest heating load, it just slowly keeps ticking away. So you're not stopping and starting your equipment all the time. The other benefit of the modular design is if one of the burners fails, you've still got the other 7 that keep burning. So you have redundancy within one boiler without needing to add a completely separate device just to maintain 100% redundancy. I just want to talk about the control. So a condensing boiler, whilst it's always more efficient than a regular boiler, it's only actually condensing, so that maximum level of efficiency, if you keep the water coming back from the field below 55 or 50 degrees. So it's not just a case of we'll bang it in and we'll save the energy. You have to make sure that you've looked at and carefully considered the pipework configuration, and also making sure you've got the right control strategy in place in the background. Just a few more examples of different types of modular designs and boilers where we've installed them. Just a case study where we've replaced one big, very old boiler. In this case, it was dated 1979, and we've installed a couple of modular small boilers, condensing boilers. And this is the example actually I was talking about, where we actually did a case study and they used as much energy heating up each year as what they did to stay open for 6 months of the year. In this case, the savings were so great based on the age of the old boiler and the operational processes. The payback period was under 4 years. So even on a small system like this, we've installed a control system, for advanced control, so we can optimize over time. Heat pumps. It's probably something that everyone's flicked around or discussed as an idea. It's an emerging technology that's improving week to week, year to year. The question is it a total boiler replacement solution or not? And there's a couple of things that you need to carefully consider when installing a heat pump, particularly in Victoria. If you're in a northern state, Queensland, or even Sydney or northern New South Wales, obviously it's nowhere near as cold up there. In Melbourne, it gets quite cold, but once you start getting to some regional areas of Victoria, I don't know if anyone from regional Victoria is on this call, but if you're looking at the Ballarat or an Upper Murray Valley, where you're getting negative ambient temperatures overnight. So as to coin a phrase, I call it the ambient effect. Essentially what happens when it's cold outside is heat pumps become less efficient and their capacity reduces. So you do need to be very careful. Obviously, on a 20-degree day, they're they're exceptional. And even down to 15 degrees, 10 degrees. But there's a crossover point at a certain ambient temperature, and it's based on the price of gas and the price of electricity at your facility. But at a certain point, there's a crossover between where a gas boiler, condensing boiler, will be more efficient still than a heat pump. And that's particularly relevant to, Victoria and Tasmania and the cooler states and cooler environments. The reason for that is basically, obviously, how do they work? And what they do is they actually take heat from the air to essentially bring the temperature of the refrigerant in the unit up slightly, and that reduces the workload that the compressor has to do. So obviously, if it's taking heat from the air, as it gets colder, there's less available heat. So these things are pretty good. It's a little bit buyer beware. If a heat pump's cheap, you're probably going to get what you're paying for. And where it's probably going to struggle and fall down is in those colder temperatures. It may work perfectly well, as I said, in a Brisbane climate, but you have to be very, very careful. And so because of this, in Victoria in particular, we're recommending that people have a hybrid system where they have both heat pumps and also condensing boilers. The other thing, when you're utilizing a heat pump to heat up from scratch, it can get quite expensive on that reheat process, particularly if you had to do it in the middle of winter. So the other thing, obviously, with some of if there's anyone from regional Victoria online, obviously the availability of natural gas isn't there, and obviously the price of LPG can be exceptionally high. So heat pumps can be a particularly good option in that circumstance, but whether or not you do away with condensing boilers just for reheat events, that it'd have to be considered on a case-by-case basis and the current price of the gas. The other thing to mention on heat pumps is we have 4-pipe units and we have 2-pipe units. The difference there is a 2-pipe unit can either run in heating or cooling mode. A 4-pipe unit can run in both heating and cooling mode simultaneously. And the advantage of that is the efficiency of the unit can go, say, from an efficiency of what we call a COP, or coefficient of performance, can go from a COP of 4 up to closer to 7. So, an extra, 50 or 75% efficiency from running it in heating and cooling mode at the same time. The issue with getting a 4-pipe is you might think, great, let's just do that. But for it to work, you need to have a simultaneous heating and cooling demand at the same time. Which, if your aquatic facility has a gym or aerobic type program rooms, it's actually a very, very good application for a 4-pipe heat pump, because you can find that as one of the rare facilities that you do actually have a simultaneous heating and cooling load. But you need to be very careful. You need to make sure that when you're sizing your 4-pipe heat pump, that it's applicable to the heating load and the cooling load, in those shoulder seasons or whenever you're looking to run it. So again, make sure you're speaking to someone experienced in scoping a heat pump before you do it. Building cooling systems. So we've obviously just talked slightly about the cooling side of a 4-pipe heat pump, and we are scoping them and in the design phase of installing 4-pipe heat pumps in aquatic facilities. But as I said, they're not appropriate. You need to have the heat load. So in the middle of summer, when it's 35, 40 degrees outside, your boilers at the moment aren't doing very much. And if you leave things running or put pool covers on, you can even overheat the pool sitting out in the sun. So you do still need a cooling source. The most efficient way of cooling or cooling your building or cooling your spaces is using a chiller that has a magnetic bearing compressor. This particular device is a Danfoss turbo core compressor, and it's arguably the best compressor on the market for chillers. It was actually designed by an Aussie. You can see here the rocker cover of the compressor. The guy was actually a V8 supercar buff and designed the head of his compressor to look like the head of a V8 supercar. But yeah, like a nice little innovation to come out of Australia. So the difference between a magnetic bearing compressor and a regular oil compressor is it's not using pressurized oil to move the components. It's using magnetic levitation. What that does is reduce maintenance costs over time. What it also does is it gives the compressor exceptional performance at low loads. And so again, I talked about turn down ratio before with the boilers. With one of these compressors in your chiller, you can literally turn down the compressor down to as low as 10%. Whereas a regular compressor, you might get down to 25 or 30%. But when you do that on a normal compressor, the efficiency goes out the window. As I said, it's oil-free, so it reduces maintenance costs over time. The other benefit is with a standard oil-based compressor system, over time, all the components get gummed up with dirty oil. And so the compressor loses efficiency over the life. So it may be okay, let's say, when you install it, but over time, the efficiency is just going to get less and less. With a magnetic bearing compressor, over time, the performance will stay the same. The other benefit of these compressors is the noise. You can actually walk up to these and touch them with your hand and barely tell they're even running. So from a vibration and noise level, they're pretty impressive. We typically in Victoria, we have a very hot and dry climate. And obviously a lot of councils, the most efficient thing to do on a chiller is have a water-cooled chiller. An open loop water-cooled chiller, obviously councils often shy away from with the risk of Legionnaires. You can get enclosed cooling towers, but you're using a lot of electrical energy to cool those. The type of chillers we tend to look at are evaporative air-cooled chillers. So we all know what evaporative cooling is. Basically, you put moisture on a pad and the air coming in to cool your compressors comes out colder and a bit more humid. So you're essentially creating a different climate for your compressor, so it operates with higher efficiency. This particular unit, we can see the pads here hanging vertically. They've got a linear actuator that when on hot days, they can actually close that pad over up against the compressor and turn on evaporative mode. But on the cooler days, when you don't need that, you can save some energy by moving away from the pad, and you save a bit of energy from the cooling fans themselves. A lot of facilities that already have a chiller installed, it's been installed without considering the volume of water in the loop or in the system. What can happen is when you don't have enough water in the system, the chiller will short cycle, or the chiller's oversized, so it basically turns on and off. When you turn a compressor on and off, it's like turning an old fluorescent light on. It uses a very very large amount of electricity or energy just to turn on, and then that settles down over time. So the more you turn your chiller on and off, or the compressors on and off, the more energy you're going to use. But stops and starts each time. And it's a very, very effective way, along with control strategy, of course, that you can minimize the energy use from your chiller. There are some other cooling systems available. Some of you may have package units, some of you may have VRV or VRF systems, or some of you may just have split systems on the wall. There's ways to optimize those as well, which we'll get into in a second. So just obviously starting to run a bit short of time, so I might push through a little bit quicker. But we've covered, your heating source and your cooling source. They are the biggest energy users in your facility. I spend so much time talking about them purely because that is where your carbon footprint comes from, your heating source and your cooling source. But obviously in your pool halls, we have large air handling units. It's a very big space that we're typically heating. So, and obviously with the chlorine involved, we can't recirculate that air like we would on a regular system. So when you're bringing in loads of fresh air, and lots of it, basically the emerging technologies are EC plug type fans. The benefits of EC fans is they're very efficient, and they come with an inbuilt speed controller, which saves cost on additional variable speed drives. The other aspect of your pool hall air handling unit is a heat wheel. This is a picture of an air handling unit we've installed at a pool hall. And I was shocked as I was fine-tuning this particular system. I think it had around 3 or 4 degrees ambient, and literally no other heating, just running the heat wheel. It was pushing that temperature of the air from outside up from that below 5 degrees up over 20 degrees and pushing towards 25 degrees. So that's literally without even using your boiler yet. So there's cheap, again, there's cheap heat wheels and there's expensive heat wheels. There is a lot of benefit to be gained from investing in a high quality heat recovery wheel. Obviously, control is a pretty critical aspect here as well. A lot of people have issues with high levels of humidity, which is, they're repainting metal fixtures on a regular basis to stop corrosion. There's a couple of ways to fix that. One is you might not have the actual set point in your pool hall warm enough. And if you turn it up, sometimes your lifeguards might complain. But basically, if you have your pool hall warmer than the temperature of the largest body of water in your pool hall, you can stop evaporation. The byproduct of that is you will reduce your chlorine and your chemical expenditure at the same time. The other way to reduce it is with better control of the fan speed. And what we try and do is basically create what we call positive pressure within the pool hall. So have more air coming in than we're taking out. And that puts surface tension on the water and can also stop evaporation by literally not letting the water come up off the surface in the form of steam. So yeah, pool halls, obviously on your regular, in your gyms, we just completed a reasonable sized project where in the initial design phase of a new gym and program rooms, they're relying on 100% return air with a little bit of outside air for fresh air. If you look at, so all the air would just circulate from the facility back through. If you're looking at, if it's a cool day outside, and you have an economy cycle and you can run 100% of your air coming from outside. We've seen facilities where basically for certain sections of the year, they're basically just turning the chiller off. And that's in the cooler months and your shoulder months. They're literally just turning it off rather than running a chiller just for a couple of rooms. They're turning it off. So the benefits of modifying existing systems to add in economy cycles / doing it from the beginning. I'm not sure why consultants don't just do this from the beginning. So yeah, just another example, a case study of a council we did, lighting, solar, boiler replacements, pool hall air handling units, new control systems, energy management systems, building analytics. I won't harp on this too much, but lots of energy, attractive payback on a pretty large financial outlay. The benefits we find in incorporating things that you might say anyone can do of lighting and solar is if we incorporate them into the one savings project, the overall payback period on replacing your larger infrastructure, the return on investment looks better. So a payback on say a big fan or your whole heating plant might be over 10 years, but if you incorporate some of these low-hanging fruits, the overall package becomes economically viable if you're trying to get it through a budget process. Nearly out of time. So yeah, just pool plan and pumping systems. Obviously your pumps are running flat out. Well, not always flat out, but they're running 24/7. We always look at opportunities to install variable speed drives, but also a lot of times there's a variable speed drive installed, but rather than slowing down the pump, someone's just half closed an isolation valve to reduce the flow. So we try and introduce different modes of operation, a normal mode, which would be at a reduced flow to what you're potentially operating at now, an eco mode or an overnight setback mode, and a full mode or what you might want to call a brown alert mode, for example, which is a scenario that no doubt everyone's all too familiar with. So yeah, what we do is we take accurate flow measurements and calculate what speeds we can run at to still obviously satisfy the flow requirements that we still all have to meet with the turnover of the pool. So yeah, just another quick case study there, which I won't harp on. Domestic hot water, different type of heat pump, CO2 heat pump. The difference is they make hotter water. Again, here a little picture of how they work. Air coming in preheats the refrigerant or the gas before it goes into the compressor, makes it hot. Hot water goes off, and simply the thing that you need to be aware of with a CO2 heat pump is they really need a very cold entering water temperature to be efficient. So you've got to make sure you get your system design right. You can't just install one and say it's going to work. You have to be taking that section of water that's from the cold water intake and heating it from as cold as possible. Again, in Victoria, what we're recommending is low load CO2 heat pumps that just kind of tick away with a chlorifier or storage. Obviously CO2 heat pumps with the increased temperature can get up over that 60 or 65 degree mark to avoid Legionella and take a bit of load off your UV filters or whatever you might have installed. And then again, as I said, in Victoria, we look at a condensing boiler gas boost system for your peak demand. Obviously, if you've got a couple hundred kids running around your facility and all trying to use the showers at once at the end of it, to help keep not only your running costs down, particularly in winter months, it's a good idea to to minimise your initial outlay of infrastructure, of still having some gas boost or gas backup there. And depending on your system, you'd have to look at it on a case-by-case basis. More often than not, it's more beneficial to have your domestic hot water system completely separate from your pool or your space heating system. But there is some cases where, depending on system design, it can still be a benefit to have them linked. So yeah, we'd have to look at them individually. Just a picture of some little CO2 heat pumps into a storage system here. And just obviously coming up on the end of time, operational improvements. Yeah, we like to get in and work with your duty managers and your operations staff and just work out what's going on a day-to-day basis. I mentioned backwashing before. When we're trying to guarantee savings and from an energy efficiency perspective, obviously, the less you can backwash, the better, because every time you do it, you're just putting more cold water into the system, which you've then got to reheat. So working out ways we can limit backwashing, or if there's over backwashing, trying to work out why that's occurring. It may be because of some other effect, maybe chemical levels or things like that. So we get in there and we'll try and work out, how we can solve the base issue. And obviously the net effect is to keep your operating costs to a minimum. Data analytics play a big part here because we can look at the performance of every piece of equipment as a whole, and determine from the logging that there is an issue, and then we can use those analytics to determine where that issue is. And as I said, work with your staff to try and improve efficiency. So yeah, what next steps to take? You're all about to come back online. Anyone that has done energy efficiency upgrades already is probably reasonably happy, and the benefits will be paying off right now. Everyone else, obviously, it's a bit of a call to action, to start looking at ways to, over time, improve your balance sheet and get back in the positive side of things. So we are basically offering essentially a free energy assessment for pools and gyms for people that have been part of today's seminar or webinar. Where we'd want to get a look at your electricity and gas bills, get a bit of an understanding on what plant equipment is in your pool heating system and your space heating system, and obviously your cooling systems. Just see where you're at with any lighting systems or upgrades, what other renewable energy opportunities there might still be that we could assist you with, and also, as I keep coming back to, building controls. It's something that seems to have been sort of lost in the ether, particularly in aquatic facilities. Not many controls companies seem to have that sort of background knowledge and the best way to run pools. So it often falls short. And yeah, obviously looking at pumping systems is a no-brainer. So yeah, if you want a free assessment, no doubt the boys can pass on our details, or you can register your interest on the link on the screen there. RJ, that's the end of our presentation for today. I don't know if there was any questions from anyone along the way.
Yeah, thanks very much, Jeremy. So anyone that's got a question for Jeremy, please drop it into the chat function, or we can trial out this new hand function. Raise your hand if you want, and we can trial sort of unmuting and things like that. So just to give a bit of background as well, so I've managed a facility and been responsible for energy performance over 3 facilities that have been involved with Ecosave in the past. I know Adrian Pano is on the line in his previous role at Maroondah Leisure as well, has dealt with Ecosave, and I think we can both sort of personally vouch for the opportunities that exist in cost savings and energy performance and efficiencies. So to give you an idea, a facility that I managed for just about a year, we had solar, we had modulating boilers, we had Tesla power walls, VSDs and everything. I don't know if we had the mechanical, the magnetic ball bearing compressors. That's pretty interesting. But it entails significant savings for that facility. So if you've got a question, please send it through. I can see there's something's come through. So we've got a question, potentially reducing backwashing versus maintaining water quality. What's the alternative? Maybe Jeremy, have you got any thought on those ultra fine filters? Like there's a couple on the market. One's a Neptune Benson that's like a zero water loss backwash. Have you got any thoughts on those types of systems?
Yeah, so I mean, obviously, we're not specialist on filtration systems. What we try and do is work closely with your current pool operators. We're not trying to shut them out of your facility in any way, shape, or form. But yeah, we're obviously there's obviously definitely advantages to any kind of new filtration system that can minimize water usage, of course. And what we find is, on some of the sand filters, even though you might meet sort of turnover requirements with existing setups, turning the pumps down too much, you're not getting enough flow through the actual sand filters and things like that for them to work properly. So as I said, when we do go through and look at these ECMs, we do engage directly with the incumbent pool plant operators, and just ensure that we're obviously maintaining filtration levels. It's a huge thing. Like when you mention to pool operators that we're going to turn your pumps down, or we'd like to, it can be a scary concept, and there's always that worry about pool quality control. So what I'm talking about is, we often find facilities, sometimes they can be backwashing more than once or twice a day. And those reasons are outside pool quality. So obviously, if the pool quality is an issue, yes, of course you have to backwash. But we do find that, sometimes there's other reasons. And also just simply the time of day. Your managers may find they've got a little bit more time first thing in the morning, so it might be easier for them to do it then. But as I said, if they can push it back to when, outdoor pools, often they'll open in the morning and then close during the middle of the day. And so the cover goes back on. And so while that cover's back on during the middle of the day, and when the sun gets on it, particularly over the cooler months, that's when I'd be looking to do that backwash, if that makes sense, or later in the day when the sun's on it. I don't know if that answers your question, AJ.
Definitely. And I wonder if the temperature of the mains water coming in, might raise over the course of the day as well. I'm not sure on that. I know one of our partner facilities, one of the platinum pools there, looking at recovering heat from the sewer mains, which just runs right outside the front of the center. And don't quote me on the specifics, but I understand that the chemical energy happening in that sewer main gives off a lot of heat. And so they're looking at wrapping pipes around that to recover heat that way. Obviously, there's the geothermal energy going in at the new Gippsland Aquatic Center, Gippsland Regional Aquatic Centers, and a number of pools putting in the Neptune Benson, so South Australia Aquatic and Leisure, Aquapulse, Werribee Outdoor. I think Rosebud has those. There's a few others putting them in and I think Oak Park has them as well. And effectively, what it is it's an ultra fine filter that uses zero water to do the backwash. Effectively, you turn it off, the sediment falls down, you vacuum it out and turn it back on. So there's some opportunities there. Jeremy, I've got a question around heat pumps. There's quite a bit of information there around heat pumps and solar and sort of matching your day load to the amount that you'd be putting on the roof. Is there opportunities
and you know, you mentioned that the boiler might be more cost efficient. If you've got sufficient solar capacity, and if you've got battery technology, does that make the use of heat pumps a little bit more cost effective in the long run, or is the install cost so high that it's sort of neither here nor there?
Okay, so yeah, good question. So essentially, we've found that to get the best payback is to literally install both technologies, your condensing boiler and your heat pump. And so rather than having, you know, two boilers, one for operation, one for redundancy, you can have one boiler and one heat pump. And if the heat pump fails, you've still got the boiler for backup, whether it's freezing cold or not, or if the boiler fails in winter, you know, or vice versa. What you need to do is employ a control strategy to optimize that you're running the most efficient piece of equipment at any one time. As I said, a 4-pipe heat pump in the middle of winter, if you've got a cooling load on your gym, is the most efficient option. If you don't have a cooling load on your gym, then a condensing boiler is likely the most efficient option. But then once you're getting up over 7 degrees, 5, 7, 10 degrees, depending on, as I said, that crossover point based on your utility bill costs, it becomes more efficient to run a heat pump again. So in the dead of winter, in the freezing cold, general rule of thumb, condensing gas boiler, or as I said, a 4-pipe heat pump if you've got the cooling load, which you may not always have, even with a massive gym. And then once you start getting out into those shoulder months and over summer, definitely, I'd be running heat pumps. So if you can find the budget, the long-term benefits of incorporating a heat pump into your system design are definitely there. And we also find that a lot of councils are starting to have, obviously targets of achieving, towards net zero over X number of years. And so some councils are converting onto 100% green energy, which basically leaves the gas systems as then the only carbon emission for that council. Because by using 100% green energy, of course, you're effectively negating any emissions from the electricity usage. Obviously, you're not negating the cost of those electricity emissions, but so reducing that gas is critical. But what we've found, as I said again in Victoria, to make the payback most attractive, it does still involve some use of gas at this point in time. But watch this space, because they're advancing heat pump technology, on a month-to-month basis, and they're even looking at now incorporating that particular magnetic bearing compressor from your chiller. They're looking at incorporating those into heat pumps into the future as well. So, I mean, over the next 3 to 5 years, there's going to be some massive advances in that space.
That's really good to note. I am just conscious that we have run out of time, and that everyone is probably due in their next meeting, or I don't know if people are listening to webinar schedules or what they're up to. But I just wanted to say thank you so much for your time, Jeremy, and to Ecosave as well. It's been great to have you guys as a partner on the series, and obviously this will be available on our webpage. But on behalf of Fitness Australia, Lifesaving Victoria, thank you very much to Ecosave and Jeremy for coming on the series. You'd be silly not to take them up on a free assessment, and you'd be silly not to think about how you can maximize your efficiency, particularly as these are 40, 50-year community assets. It's kind of a no-brainer to get some bang for your buck back, and to reduce our carbon footprint as well, thinking about our sort of global responsibility in that space, especially as high energy consumers. Anyways, thanks everyone for listening in. Thank you, Jeremy. So I will end the recording and end the session now. If you've got any further questions, please feel free to send us an email at assessments@lsv.com.au. which is just up on the screen now, and we can pass that on to Ecosave. Likewise, they've dropped in the chat just their details as well. So thanks everyone for listening once again.
Thank you, RJ.
Thank you.